All right, we are here with our last type of rocks, our metamorphic rocks. And I ask you, what do the following pictures have in common? And I don't know if you've ever watched the Power Rangers when you were little, but you do know that a butterfly, because I know every single elementary school does the butterfly. The caterpillar into the chrysalis and the caterpillar and the butterfly. So you're noticing changes. So metamorphic rocks form when sedimentary, igneous, or even metamorphic rocks undergo some type of heat and pressure, extreme heat and pressure, and change. One thing to keep in mind, there is no melting involved. Once a rock melts, it solidifies, and that is an igneous rock. So these are extreme heat and pressure that does not involve melting. Okay, so if we go to our reference table, you will know, or you will see, we have foliated versus non-foliated metamorphic rocks. And that is basically how this table is broken up. Are you foliated or are you non-foliated? So if we go down here, foliated, if you take a rock before metamorphosizing, touch scrolling is enabled. I don't know what that means. Okay, so if you take a rock before, you notice that the minerals are all in different arrangements, but foliation, because of that pressure is going to cause the darker minerals to line up, the lighter minerals to line up, and you start to get these lines of white, dark minerals that are taking place. Now, our foliated rocks are caused when plates collide, and that pressure causes the rocks to fold and causes those minerals to line up, and that is called alignment. Banding is when you have extreme pressure and you're getting these like waves of minerals, and that happens only in the rock gneiss. So if I show you the rock gneiss, you can kind of see that banding taking place in this picture, the waves of the white or the dark and the pink or the dark and the white minerals. I call it the zebra rock. Kind of looks like a zebra, whether it's white and black or pink and black. Where a non-foliated rock, such as marble, you will see different colors, but you won't see that line up of the minerals. Okay, so if we go back, so you'll answer those questions. This leads us to the type of metamorphic rocks. You can either have regional or you can have contact, or it depends on the situation where you can have both. So regional is that mountain building. You have the two plates, they're colliding with each other. That collision is causing a ton of friction, a ton of heat, a ton of pressure that will change the rocks. So any type of mountain building, you are going to find metamorphic rocks, like the Adirondack Mountains are all metamorphic rocks. The Taconic Mountains, all metamorphic rocks. So any type of mountain building, you are definitely going to see most metamorphic. Okay, contact actually occurs when you have the magma, and the magma is solidifying to form the igneous rocks, but the heat that it produces around, without touching around, you're going to get a small section of metamorphic rocks that are formed from the heat produced by the magma without melting that rock. Okay, so we have what's known as, if we go back to our reference table, low grade versus high grade metamorphism. And low grade talks about the pressure and the heat. So low grade would be very little pressure, very little heat to create the rock, and high grade, extreme deformation, lots of heat, lots of pressure. We talk about a parent rock. So a parent rock is the rock that it was before it underwent this heat and pressure. So like your parents, you sort of resemble them. So the parent rock will resemble the new rock. So slate is changed from shale. So shale undergoes heat and pressure and changes into slate. Slate's thinner, it's more layered, and it's shinier. Okay, if slate goes under extreme heat and pressure, it could turn to phyllite. Then phyllite could turn to schist. That's pronounced schist. And then it could turn into gneiss. This word is pronounced gneiss. You'll notice gneiss has the only rock that has banding. Those are those waves of the different colors that you see, the deformation. You can even see it in its map symbol. Parent rocks, quartzite. Well, when quartz sandstone undergoes heat, it will turn into quartzite, and limestone or dolostone will turn into marble. So marble will definitely react with hydrochloric acid when placed on it. That's why a lot of your marble in your house has a protective coating on it, because it does react to acid. So any foods, if you have a marble countertop, any foods with acid like lemons or juices or ketchup will react with that marble. So it's really important to have a protective coat on marble. And metaconglomerate, when conglomerate is stretched out and put under heat and pressure. Going back to the notes. Metamorphic rocks form on the boundary, or contact metamorphic rocks form on the boundary of igneous and sedimentary rocks. So you'll notice in this drawing here, this is the igneous rock, C. All right. It's intruding into the sedimentary rocks that are already there. So these, where I'm putting blue lines, these were your sedimentary rocks, and it's intruding into it. So as it's intruding, it's giving off this heat, right? And the heat is transforming these sedimentary rocks where these little tick marks are. That's called contact metamorphism. So you're going to find a thin layer of contact metamorphic rocks along the boundary of igneous and sedimentary rock. So for example, this is limestone. On the boundary between the igneous and limestone, you are going to get marble. This is sandstone. On the border between igneous and sandstone, you're going to get quartzite. And those would be the type of questions that they're going to be asked. And I think I gave you some of those questions there. So watch this video over if you need to. Answer the questions before you check my answer key, which has not been released. I will release it tomorrow. Okay, so I would like you to do the work before you look up the answer key. Any questions, send them to me. Hope this video helped. Hope you guys are doing well, and I will talk to you soon.